Hello everyone. As we discussed in the last video, what is PPO and what is GRPO, how they works. Let's revise once again. So PPO stands for proximal policy optimization, and GRPO stands for group relative policy optimization. PPO is used by OpenAI to train its model, and it takes almost 100, as they claim, it takes almost $100 million for them to train their models. And PPO internally uses three models: reward model, actor model, and the critic model, while the GRPO, which is brought by DeepSeek in January 2025, uses only two models: reward model and the actor model. So I, we already discussed all these things, how they work, how the GRPO actually works in a replicated reward function way. So there are certain problems which I'm going to discuss today in the reward model, or in the reward function which I created, and how they are going to solve by reward model. So one of the problem is reward hacking. So again, as the context of this uh, is the kids robot, so we are going to focus more, like our answers are more focused regarding the in the context of the kids, so that the kids can easily understand what are they getting from the robot. So the some of the preconditions, prerequisites, the answer should contain more of like emojis, and it should have some of the fun words, as I discussed in the previous demo, and some of the words like a, like, and some of these words will get some good scores. Those are the scores which reward function will give the reward to each answer. But again, there are certain penalties if they are using some heavy words like furthermore, consequently, or some jargon. So there will be certain penalty and they will be deducted. Now this is what we discussed in the last video. Today we are going to see couple of problems. The first problem is reward hacking. So what is reward hacking means? Reward hacking, it means you have added some of the response to the data set to the reward model, which does not make sense, but it has a lot of emojis and it is kind of gibberish. So I'll show you what does it I mean. So if you see here, the question is, what is gravity? I have given four answers. So again, as I discussed in the previous demo, uh, GRPO base compares generate four answers. Out of them, it compare all the four and get the best out of them. And that was the problem with the PPO, because PPO has the one, so no compare, and that's why the critic model they brought into the picture. So here I have given one of the answer is gravity is like emoji is good, but gravity is cool. Big hug does not sense. But so if you see, this answer does not make any sense. It's kind of a gibberish, emoji. But when we compare this, when the reward function started giving the uh, score to this function, if you see here, the first answer which we have is like gravity is a fundamental force. Again, it has one fun word, so it got 0.5. But the second answer which I have, it does not make any sense, but I intentionally add some of the emojis and some good words, but they do not make sense. But because it fulfill all the preconditions, so the score is 5.0. Third answer, it has 2.5, and the fourth answer is 4.5. The clear answer is second. So if you see here, the clear winner is response 2, which is like gravity is like, which is not the right answer because it does not make sense. So this is called reward hacking, and that's the problem which is solved. This is like a replicate. This is kind of a demo which I created for the for a reward model, so that we can understand what is reward hacking. So that is the problem reward model sorted out, because reward model understand what is gibberish, and it see the pattern, so it automatically solve this problem. So that is first of the problem is reward hacking. The another problem is reward normalization. So what is a reward normalization? Is when the answers are very close to each other. So if you see here, the question is, what is water cycle? The water cycle is nature recycling system, the amazing. So when according to this reward model, the reward is given to each and every answer is 0.5, 1.0, 1.0, 1.0. So all the four answers are very close to each other. So there are no clear winner here. So reward model get confused which one it should pick, which one it should not pick. So this problem is actually solved by the j score J score is a very old approach in the mathematics. So basically, how it works, there is a formula for J score is like they have A minus B, where A is like individual score, B is the mean, and the C is the standard. And so that's what they are doing here. That's the they are taking all the score, getting the standard out, and that's what it is. It was invented by Carl Pearson in 1894. So that's using the J score, they are able to find out the clear winner is response 2, because the it has 0.58 score. So those are some of the problems. The another problem is when the reward function reward the responses which are generated by the actor are totally drifting away from the base model. So when we are doing the training, the GRPO trainer always has a reference model. It throws the reference model, so it compare at the same time whether the reward is not taking it away from the original. So that is called the catastrophic forgetting. Like, okay, it's too much diverted from drifted from the original. So that is something is handled by KL. And so these are some of the problems of the reward model which is solved by GRPO. Okay, so now today we are going to start with the actual GRPO training, GRPO model training. So I start with like some of the basic installation of the module, then import of those uh, Python libraries. Next, I have already set these DPO data sets and the PPO data sets. As we mentioned, the reward model required the DPO kind of a data set where you have the prompt and the choose and the reject, so that the reward model can understand the pattern, what pattern you are looking for. So in our case, because this is a kid friendly robot we are working on, so our data set more like this is the DPO set, like what is gravity, so this is chosen, this is rejected, something like that. And also have the PPO prompt, which is like so PPO prompts are like a simple, there is no answers. So that's the beauty of the GRPO, like they are autonomous, we are not providing any answer to the trainer, they are going to choose the answers based on the reward model. So as you can see in the PPO, there is simple prompts, direct answers, why does some animals uh, glow, and all those. So there are, I have generated almost 1000 questions, or yeah, 413. Yeah, so these are the data set which we are going to use. So here again in the next cell we are doing the pandas to validate the data set, that we are, if for the DPO data set we have rejected, we have chosen, we have prompts, all those things, whether it has emojis and it has good words and count is greater than 0. So all these things we are checking here. So the total I have created data set for 1000 for DPO. So these are the great questions, simple, rejected, all these are clear. Now the next thing is we are loading the base model. So here if you see, here we are using llama 3.21 billion instead BNB 4 bit. So what is BNB? It's a bit and byte, and 4 bit is basically it's a quantized uh, version. So that's what it meant for. And here we are loading that base model. The next step is to train the reward model. Now here we are doing the reward trainer, and this is our reward model, we are training reward model the same, using this is our directory, and the model is basically the reward the base model which we are using, and we are saving it. The reward model is saved. Now the next let's just test the reward model which we have trained here above here using the reward trainer, uh, to see the gravity like earth giving. So uh, here we are, the test good, test bad, hijacked. So all the scenarios which we have test, hijacking, is it hijacking or not. So as you can see, the answer, one of the good answer should be is like sorry, reconnect, like imagine cool, cool, amazing, and some of these. So if you see here, it has hacked answer and bad answer, good answer. So let me show that. So here if you see clearly, the good answer is 14 point, bad answer and hacked answer. So even though the hacked answer has a good score, but the clear winner is the first one, because the reward model can easily understand that it is gibberish. It does not make sense even though it fulfill all the criteria of like having a good answer. So those are the things which reward model takes care of by itself. The next thing is like a GRPO training. So the as I mentioned, the GRPO training, GRPO works with the two models, the reward model and the actor model. So here is the GRPO trainer. The model is, this is the actor, which is actually the, so flow is like the actor generate the response, and so it generate four response, reward give the reward, and here we have all, this is the actor. Then this is the reward model. We are using the reward function to generate the to create the rewards for those, and here we are doing the training. The next thing is base versus evaluation. So what I did is like doing the comparison the base model and the GRPO model for the sum of the questions, like what is gravity, what is sky, why the sky blue, how do I fish, how do fish breathe underwater. So if we see that the now notice that the prompts, the GRPO dataset was empty, straightforward questions. There was no answer. So all the answers which are generated are autonomously using the reward model. So the answer is what is gravity? The base model given the answer, gravity is a fundamental force of nature, and GRPO create kind of a same answer, little bit of diverted. But the score, if you see the score, the base model given 1.38, while the GRPO have given the score 4.41. So improvement is almost 220.5%. The same thing is for other questions. Improvement is 15%. And how do fish breathe? So score here, the fish breathe under by using gills and fear under by oxygen rich water. So here again the improvement is 202.7%. So this is complete autonomous learning by the model. There is not so there is no human intervention here. Once you have created the DPO data set and you created the questions, GRPO will automatically learn it from your DPO data set. You don't have to give any questions like how we were doing in the SFT, like supervised fine tuning. We were giving the questions and the answers. So I'll show you in the SFT data set. We were giving the instructions and the response directly. Now here we are not giving any response. It is created automatically at the runtime. Now the next thing is simple. Now the model is trained using the GRPO, the learning completed. The next thing is GRPO. We are creating the GGUF and pushing to Hugging Face. So as I have already posted, this is the name of my model, robot V7. So this is my robot V7. Now I'll go to my Pi, and oh, I already pull it. So let's see. So this is what I have already created, and I created a file, model file, where I am using this and setting up the system prompt. You are a fun kid. This is like a system prompt which we have talked about, like a prompt engineering, setting up the prompt and creating that system prompt to tell the model that it is a kid friendly model. So control X. Now if we are going to run Olama run, and if we say what is gravity, okay, so it says like here's the explanation emoji, imagine you are running around. So it's more like a clear kid friendly. Now let me run this through my